Okay, proof masters. Let's get proofing. So this is the one I think ended up on pink paper. Not that it matters a lot, but just so you guys know, that's kind of where we are now. And we have to prove that the angle CLU equals 50 degrees. So if this is your first video, you probably didn't see me do this in the last one, but you know, this three-letter thing, again, gets kind of confusing sometimes. I mean, we're talking about angle CLU, LCU, UCN, NUL. Is this too much? I mean, there's another way to name angles. We know that. We've talked about that. And that's simply by calling it a direct name or another variable. So I'm going to call this angle little a, little b, little c, little d, little e, little f, and little g. And the reason I'm going to do that is because now I can, instead of saying I want to prove the measurement angle CLU is 50, I can just say I want to prove the measurement of angle G equals 50. And I think that's a little bit cleaner. It's a little bit easier to kind of determine what's going on. Okay, so that's kind of how I'm going to set this proof up. Just like any proof, what we really have to do is have a plan first. Like if we don't have a clear sense of where we're actually going or why it makes sense in our own heads that this angle is 50, we have no hope of completing it. So let's start right here. I mean, if your attention has been drawn to the spot already, whenever this aligned with multiple angles, let that start happening immediately. So if all these angles are on a line, we know they're 180 degrees. That's linear pairs. That's 50, that's 70, 120. That makes this one 60. Oh, look, we're in a triangle. If that's a triangle and that's 90, that's 60, E's got to be 30 degrees. If this is 30 and we're given that this is a 90, that means this has got to be 60, 60, 70. That's a triangle. That's got to be 50. So that's our plan. That's our flow. We're going to start here, usually using linear pairs, take advantage of the triangle, take advantage of angle addition, another triangle, and finding G. That's our plan. The first thing we should do is probably write in our givens, though. Okay. Um, the givens here aren't stated, but they're all from the diagram. So let's just go ahead and make a list. Let's first I have the measurement of angle A equals 50 degrees. That comes directly from this piece right here. Again, I'm using the new angles that I measured or named. Excuse me. That's messy. The measured angle B is going to be 70 degrees. Again, that's a given right from here. That that may seem like it's it, but there's actually a couple more. The measurement of angle D. Oh, excuse me. Let me rephrase that because I didn't put it correctly. Angle D. Okay, angle D is right. Okay, and angle E plus angle F is also right. Okay? Those are the things that we're told. Now, if you're wondering how I got those right angles, it's actually marked in the diagram. Very sneaky way to do it, but perfectly fine way to do it. Those are going to be 90. I'm sorry, D by itself is going to be a right angle, and if I add F plus E together, that's also going to be a right angle. Now, before I jump into my proof, I think I need to take advantage of this. In fact, you heard me slip a couple times already. So why, if I know if it's going to be an angle measurement, and in the end I got to find angle measurement, let's convert these right angles to angle measurements. The measurement of angle D is going to be 90 degrees. And if I take the measurement of angle E plus the measurement of angle F, that's also going to be 90 degrees. And that's going to be from the definition of a right angle. Okay? And again, notice the arrow because that's going to be generated from our given statements. And that's just something that we need to kind of get in the habit of. Like if we have a given statement but we know it can be taken a step farther, I say go ahead and do that initially. Don't wait until it's necessary in the proof. Do it like right now. And in fact, if you watch my previous video, that's a mistake I made. I didn't do that, and right in the middle of the proof, I had to go back and lose momentum and actually make those statements. So anyway, just for what it's worth, let's go ahead and extend our given statement for this one as well. From here, now let's go ahead and write our proof. We said we're going to use this as a starting point, the fact that we have linear pairs here. Um, so let's do it. Now, the kind of thing to keep in mind about proofs is that we're going to kind of follow a very direct order. We always have to start with a structure. In other words, we're going to use our diagram to actually justify a relationship. Once we have that relationship, and that's mostly going to be an equation, we're going to take that relationship and then substitute and solve to find actual values, which we may use to start the whole process over again. So that's what we got to do first. We got to start with this structure. So we're not going to talk about the measurements yet. We're going to talk about how the angles are actually related to one another within the diagram. And I would argue if I take A and B and C, if I put them together, that forms a line. If they form a line, they are supplementary, and that's because of the linear pair postulate. So that's how I'm going to start. Angle A, angle B, and angle C are supplementary. And that's going to be because of the linear pair postulate. Now, that comes directly from the diagram, so there's no connections to be made here. But once I have this established, now I can actually start introducing the relationship. In this case, an equation. If they are supplementary, then by definition, the measurement of angle A plus the measurement of angle B plus the measurement of angle C has to be 180 degrees because that's what the definition of supplementary is. Okay. And notice I kind of drew my arrow as I went. That's coming directly from the idea above it. That's why I'm drawing it like that. Now I have the relationship. Now I can actually substitute values and solve. In other words, I want angle C to begin with. I don't want angle A and B, but I think I know what they are. So I can take these variably defined angles and replace them actually with numbers. That's what we're going to see next. So instead of A, I'll write 50. So measuring angle A is actually just 50 degrees. The measuring angle B is 70. And the measuring angle C, well, I'm trying to solve that. Okay. Now, in terms of justification, this is because of substitution. That's what substitution means, right? Take out one thing, put another that's equally valued. Now, where is this coming from? Well, I'm modifying this equation, so I'll draw an arrow from here. I think the other place it comes from has to be from the givens. So I'm going to draw an arrow, and that's kind of weird, but I'm going to draw an arrow from my givens as well. So just imagine you can see that line. I know it kind of went off the screen. From here, what's our conclusion? Well, measurement of angle C is going to be, well, 50 plus 70, that's 120. Take it away from 80, that's going to be 60 degrees. And that's just because I'm solving. Where did I get that? Well, I just modified that equation, didn't I? So that's kind of our end of section 1. Like we're now to where C equals 60 degrees. Okay? Uh, now we have a triangle. Now we have this guy. Ultimately, we want this guy right here. We want angle E. But to do that, we got to use the relationship slash the structure of a triangle, the relationship of triangle sum theorem. That's where we're going next. So let's go ahead and get that in our proof. If I'm going to utilize this triangle structure and the relationship of triangle sum theorem, now we don't have to justify the structure first because the triangle's there because, well, it's a triangle, it's in our diagram. So we can start right with the relationship. The measurement of angle C plus a measurement of angle D plus a measurement of angle E equals 180 degrees. That's our relationship. That's going to be because of the triangle sum theorem. Again, that comes from a diagram. No arrows needed. I think we're good to go to move to our next one. If we did a relationship already, now let's substitute and solve. So instead of C, let's replace it with the value we know is C, which is 60 degrees. Instead of D, let's replace it with the value we know. That's going to be 90 degrees. And the measure of angle E, well, we're trying to find that. So we'll solve for it. We're definitely substituting here. But let's be careful about where. Well, we're modifying this equation, so that's one arrow. Oh, look at this. Measure of angle D equals 90. We did use that from our given. And the fact that it's 60 comes from our previous step. From here, now it's a simple solve step. Measure of angle C. Excuse me, measure of angle E. 60, 90, that's 150, so that should be 30 degrees left over. And that's because I am solving like a boss. Okay, so where are we? We got to 30. We now determine this is 30 degrees. We now need angle F so we can use a final triangle to finish our proof. So again, think about structure, relationship, sub, and solve. I know that's I just erased it, but I like that so much I need to rewrite it right away before I forget. So that's going to be first a structure, then a relationship, and then sub slash solve. Okay, so we need to figure out how to first identify a structure, then a relationship, and then a sub and solve. Well, I think a relationship is kind of set for us. It's a right angle. E plus F equals 90 degrees. I mean, we have that right here. E plus F is right. E plus F equals 90 degrees. I think we can just piggyback off this. I don't think we have to even start with a structure. We identify the structure as part of our givens. So if I take this idea right here and extend it, because I can use this E plus F equals 90 degrees, and I know E is 30 degrees, I know that the measurement angle F plus 30 has to be 90 degrees. Now we're just substituting here. Like the structure and the relationship was actually written in our givens. Structure is that E and F are right, E and F is right, and then like together they are right. Then E plus F, the measurement angle E plus the measurement angle F is 90. Well, now we can substitute off that one and then quickly do a solve. The measurement angle F equals 60 degrees. Okay? So these are all the pieces we need to use our final triangle sum to get angle G. Triangles are structure, relationship is triangle sum theorem. Now let's write that in so we can do the substitute and solve. Allow me a quick second here. I'm going to go ahead. I want to go ahead and recap this. Because I have to scroll down, I kind of want to be able to see the picture while I'm doing it. I don't have the luxury of a piece of paper where it's all on the same page. Okay, so we have all this so far. What we're going to need is a final kind of triangle. Um, Triangles are structure. Okay, triangles are structure. Relationship will be triangle sum theorem. So the measurement of angle B plus the measurement of angle F plus the measurement of angle G equals 180 degrees. That's going to be because of the triangle sum theorem. Okay. Now that comes from the structure. That doesn't come from anything directly. Um, but that's going to be this triangle right here. All three pieces add to 90. Now I think if the relationship's established, we're ready for the substitute solve part. So let's rewrite this equation. Measurement of angle B is 70 degrees. Measurement of angle F is 60 degrees. We just found that. And the measurement of angle G, well, we're trying to find that. We'll leave it as a variable. Okay. Now this is going to be because of substitution. Okay, but let's be careful from where. Modified the equation. Here's where I grab the 60. Well, whoa, back up, Mr. Collins. Boop. Here's where I grab the 60. And the 70, well, how did I know that was 70? Oh, look, it was a given statement. I need to come all the way back up here and connect my given statement. Okay. Oops. Whoa. Okay, so this, and I apologize for that delay, but that came from three different values. So we have the 70 coming from the givens, we have the 60 that we solved in the previous step, and of course the equation we're modifying. So we're pretty close to the end here. We just have to go ahead and solve this guy. Measurement angle G, therefore, has to be exactly what we were asked to find in the beginning, is 50 degrees. And because we're simply solving here. So that comes from the previous statement. Guys, this is a good proof. QED, we're done. Done, done, done. We've reached the end. So let me do let me just do a really quick slow scroll here in case you want to check your work. Okay. Now, I am aware how complicated this looks, guys. Big proofs like this, real proofs are complicated. But again, think about the steps. They're really, really simple. Linear pairs, triangle sum, um, complementary, triangle sum, That's all it is. Now the steps have to be vetted out, and I know ultimately that's where we're having the most trouble. But again, I encourage you. Oh, hello. I encourage you to go ahead and review this. I mean, look it over again. Don't just look at it once. Use it as a study tool. So if you're in class, check it out again. If you're here at home, run it a few times, study it. Okay? So that's what I have to say. Now we have a couple more to go. So I'll see you guys in a sec.